All right, so let's see this particular problem now. So in this problem, we are given an array of integers, right? And what they are saying is that this array is actually a circular array, right? And what we need to do is we need to find the maximum subarray sum that we can get if we assume this particular array to be circular again, right? And what do we mean by a circular array? Essentially, what we mean is that if this is the array, right, then the last element of this particular array, if you see, the next element of this particular last element of the array would actually be the first element of the array itself, right? So these two, last and the first element of this particular array, would be linked, and such an array we call as a circular array, right? So now what we need to do is we need to find the maximum sum possible from any subarray of this particular array, right? Including the subarrays which are circular, right? That means they might start from the end anywhere, right? And might go towards the beginning, right? They can follow a circular fashion as well, those subarrays, right? So we have to now consider those subarrays also which are circular in addition to the ones which are anyways contiguous, right? So to find the maximum contiguous subarray sum, this particular question we have already solved previously, right? I will attach the link of that particular question with this particular video, and you can first check that particular question. We have seen in detail how to actually solve that particular question to actually find, the maximum contiguous subarray sum, right? Where there is no circular array or a circular subarray, right? So that we have already seen, right? So in addition to contiguous subarray now, we also have to consider arrays which are circular now, right? So that is the only addition to that particular problem. We have to consider the circular subarrays also now while we are calculating the maximum sum, and whichever the maximum sum is for any of the array, either contiguous or circular, from this particular array, we just have to return that particular sum, right? So that is the question. Now maybe you can just give it a thought, right? It will be related to, what we did in the last question to find the maximum contiguous subarray sum, right? But you will have to give it a little thought. There will be a trick over there that you will have to identify. I will suggest now maybe you can just pause this video and try to think of a solution around that, and or maybe think of any solution. There can be even other solutions, there can be better solutions also. So you can just think of any solution, and once you are done, you can just come back and check the solution here. So now see, to solve this particular question, so as we talked about, the maximum subarray sum could either come from a contiguous subarray of this particular array, or it could come from a circular subarray of this particular array, right? So what we can do is we can actually first find the maximum contiguous subarray sum, right? And for that, we already know how to find that, right? We can just follow that and we can find the maximum contiguous subarray sum, right? That will be one part. And then what we can do is then we can find the maximum circular subarray sum separately, right? That is the maximum sum possible from any circular subarray, right? And then whichever is greater, either of the circular subarray, the sum is greater, or the contiguous subarray, the sum is greater. Whichever is greater, we will just return as the maximum subarray sum for this particular input array, right? That will be our output. So that is something that we can do. Now to find the maximum contiguous subarray sum, as I said, we have already discussed that in the last question, and we can follow the same method, right? So what we can do is we can keep traversing this particular array, and we can keep adding the current element to a sum variable that we are maintaining to track the current sum, right? So for example, the current sum to begin with will be 0, right? When I come at the first element, I will just add this first element to my current sum, and it will become 8, for example, in this example, right? Then I will go to the next element. I will again add that new element into my current sum, and then, now it will become 0, right? Then I will go to the next element. I will add the new element in that current sum. Then I will go to the next element. I will add this particular element to the current sum. I will keep doing this till I hit a point where my current sum becomes negative, right? And the moment my current sum becomes negative, what I will do is I will just reset my current sum variable to 0 now, right? Because see, since my sum till that particular point will be negative, there is no point in moving ahead with that particular sum, because definitely it is going to take away something from the next elements, right? So it is only going to make the sum of the next elements, the upcoming elements, smaller by somewhat, right? But it is not going to add anything to that particular sum. And since I'm interested in finding the maximum sum possible from a subarray, I should like reset my subarray at that particular point in time, and I should start afresh. That's why I will just reset my sum variable to 0 wherever my current sum becomes less than 0, right? That's what we did in that question as well. And that's how I will just keep traversing this particular array. And at every point when I'm actually calculating my current sum at every element, I will just keep comparing it with the maximum sum that I've seen so far, right? And if the maximum sum that I've seen so far at any point in time becomes less than the current sum at the current element, I will just reassign, the current sum to the maximum sum that I've seen so far, right? And that's how I will just keep processing. I will just keep progressing, and uh, once I have traversed this entire array, I will just return the maximum sum that I've seen so far till the end of the array, and that will be my maximum sum possible for a contiguous subarray, right? So that is how we are going to solve the first part for the contiguous subarray. Now for the circular subarray, now if you see over here, so what is a circular subarray, right? So circular subarray, if you see, for example, this minus 11, 12, 8, minus 8, so this is a part of this forms a circular subarray of this particular array, right? But if you see this particular subarray in a different way, so you will see that, this subarray I got by subtracting these contiguous elements from the entire array, right? If I just subtract, these three elements from the entire array, I will get this particular circular subarray, right? So essentially what I can do is that instead of maximizing the sum of the circular subarray, any circular subarray, what if I try to minimize the sum of the contiguous subarray, right? What if I try to find the minimum sum possible from a contiguous subarray? Just as we found out the maximum sum possible from a contiguous subarray, what if I do the reverse now? I find the minimum sum possible from a contiguous subarray of this array, and that if I just subtract from the overall sum of all the elements of this particular array, I will get the maximum sum possible from a circular subarray now, right? If I just subtract, the sum of these three elements which are contiguous in nature from the overall sum, I will get, this sum of this particular circular subarray, that is minus 11, 12, 8, and minus 8, right? So that's how I can just try to minimize the uh, sum of a contiguous subarray of this particular array. I can just try to find the minimum sum possible for any contiguous subarray of this particular array, and that I can just subtract from the overall sum, and I will get the maximum sum possible for a circular subarray of this particular array, right? And then once I have got this particular maximum sum possible of a circular subarray, I can just compare it with the maximum sum I got for a contiguous subarray, right? And whichever is greater, that will be my output. So that was the trick. I hope you understood it well. And see, talking about the time complexity over here, we are just going to traverse this particular array twice to first find the maximum sum possible for a contiguous subarray, and then to find the minimum sum possible for a contiguous subarray. And so we will be just traversing this particular array linearly twice. And so the order of time complexity will be order of n, right? Big O of n. And talking about the space complexity, again, since we are not using any extra space over here, it is going to be constant. It will be order of 1, right? So that is the entire solution. And also, like, just to talk about how to find the minimum sum possible for a contiguous subarray. So essentially, we are going to do the same thing. We are just going to keep adding, each element to the current sum variable, right? And now what we will do is at any point in time, if my current sum becomes greater than 0, right? So earlier, while calculating the maximum sum possible for a contiguous subarray, we were checking if at any point in time my current sum becomes less than 0, then I'm going to reset that current sum to 0, right? Now I'm going to do the reverse. Whenever my current sum becomes greater than 0, that's when I'm going to reset my current sum to 0, and then I'm going to proceed further, right? For the same reason, because if my current sum is greater than 0, then it is only going to make the sum of the next elements of the upcoming elements bigger, right? It is not going to make it smaller, right? And since I'm interested in the minimum sum possible, I should not proceed with this particular sum. I should reset my sum over here and start afresh, start a new subarray, right? So that's why I will just keep checking at every element. If my current sum, if it is greater than 0, then I will just reset it to 0, and then I will proceed further. And obviously, like before, I will be keeping a track of the the minimum sum that I've seen so far, and I will always keep comparing it with my current sum. If at any point in time my minimum sum that I've seen so far becomes greater than the current sum, then I will just reassign the current sum to my minimum sum seen so far, and at the end of the entire traversal of this particular array, this minimum sum that I've seen so far will become my final output, right? So that is how I can find the minimum sum possible for a contiguous subarray, right? So I hope you understood it completely now. Now maybe let's quickly jump to the IDE and code this particular solution. All right, so now let's implement the solution that we discussed. So what I will do is I will first create a function called circular subarray sum, right? Like this. It will accept an integer array, right? And now what I will do is, see, as we discussed, to actually calculate the circular subarray sum, the maximum circular subarray sum, we will have to actually calculate the maximum subarray sum, like a maximum contiguous subarray sum, and also the minimum contiguous subarray sum, right? We need both of these sums to actually derive at the maximum circular subarray sum, right? So what I will do is, I will, before implementing this circular subarray sum, I will just create two more functions for the minimum contiguous subarray sum and the maximum contiguous subarray sum. So I will create a function first of all to find the minimum subarray sum, like this, and this will again accept an integer array, and it will also accept the length of the array, right? Now what I need to do is I can just declare, two variables, sum and minimum sum, right? So this sum will actually be my current sum, and this min sum will be the minimum sum that I've seen so far to track that particular value, right? And initially I will just initialize both of them to the first element of the array, right? That's where I'm going to start with, right? Now, and also like after initializing both these variables to the first element of the array, I will just check for once if my current sum is actually greater than 0 or not, right? Because if you remember, if at any point in time my current sum becomes greater than 0, then I have to reinitialize my sum to 0, right? So if it is happening at the first element itself, then I have to handle that over here, right? That's what I'm doing over here. Now what I can do is, now I can run a for loop to traverse this entire array starting from the first index till the last index, like this, right? And like this, right? And now what I need to do is I have to keep adding the current element to my sum variable, like this, right? And after adding it, I will keep checking if, the minimum sum that I've seen so far is actually greater than the current sum or not, right? If so, I will just reassign my minimum sum, right? That's what I'm doing over here. I'm taking the minimum of the current sum and the minimum sum that I've seen so far, right? And reassigning it to the minimum sum. That's what I'm doing. And then what I will do is I will do the same thing over here, what I did for the first element. I will keep checking at any point in time. If my current sum is now greater than 0, I will just reset it to 0, right? And at the end of the entire thing, I will just come out of the for loop once I have traversed the entire array, and I will just return the minimum sum, right? This will be the minimum sum possible from a contiguous subarray of the input array, right? Now, I also need a function to calculate the maximum sum possible from a contiguous subarray, right? So for that, what I will do is I will just copy this particular function. I can just rename the min to max, right? And also over here, the variable names I can change like this. And see, now what I have to do is, instead of checking if my sum is greater than 0, I have to check if my sum is less than 0 at any point in time. And that's where I have to reset my sum to 0. So I will make that change. And then I have to essentially replace all the variable values like this, right? Right. So now I have like done all the changes, I guess. And also over here also I have made the change. So I think we should be good. And yes, instead of min, now I have to take max, right? So we are good now. We have both the functions to calculate the minimum contiguous subarray sum and the maximum contiguous subarray sum possible, respectively. Now what we need to do is we can just implement this function now. We can first of all take the length of the input array and capture it in variable n, right? Like this. And then I can just initialize my current sum variable or the overall sum variable this time to 0. Now what I need to do is as we had discussed, to find the maximum sum possible from a circular subarray, I need to actually subtract the minimum sum possible from a contiguous subarray from the overall sum of the array, right? So to get that overall sum of the subarray, I will now run a for loop, right? For I in range n over all the elements of the array, And now what I will do is I will keep adding, the current element to my sum, right? And at the end of the for loop, when I've traversed the entire array, I will get the total sum of the array, right? That's what I'm doing. And then finally, I just have to now return, you know, uh, the maximum among the maximum subarray sum, right? I can just call this particular function that I declared above, and this will accept array and the length of the array, right? Or it will be sum minus minimum subarray sum, right? That's what we discussed. This will be corresponding to the maximum sum possible from a circular subarray, and this will be the maximum sum possible from a contiguous subarray, right? So that's what we are doing here. And again, I will send array and the length of the array itself, right? That's it. Now, I think this is pretty much it. Once we return once we take out the maximum value from these two expressions, that will be my maximum sum possible for a circular subarray, right? So that's what we had to do in this particular question. Now maybe we can just quickly test it with the sample test case that we saw earlier. So I will just declare that particular array over here. Let me just quickly copy it over here, right? And now what I can do is I can just print the output of this particular function, circular subarray sum, over this particular array, right? That's it. Now let me just run this and check the output. It should be 22 as we saw in the explanation part. So let me run again and you get 22 over here, right? So this is the entire solution for this particular question. I hope you understood it well. And now I will see you in the next question. Thank you.